Hello everyone, this is Yuzhou Chen. I'm the PI of this GMKG project, and it's very an honor today to give the tutorial, which is prepared by me, my student Chenguang, and Javad, so who is supervised by Dr. Huanmei Wu at Temple University. And here you can see we have a very powerful team. So me from UC Riverside, Huanmei and Chiu from Temple University, Yin from the University of Texas at Austin, and Omar from the University of Central Florida. And it's a very powerful and diverse team. So we have the people from the computer science, statistics, bioinformatics, and public health. And this project is funded by the NSF Proto-OKN program, and our federal agency partnerships is National Institute of Justice. So here, first I will give the high level the overview of our project. So the essential goal here is to create a knowledge graph KG system so that it's a dynamic, responsive, adaptive, and multi-faced knowledge graph. So that will provide a comprehensive understanding of the social, economic, and the political factors so that contribute to the homelessness. And our GMKG will leverage the existing surveys and the resources to support the people experiencing homelessness, so namely PEH. And additionally, the GMKG can provide an automated end-to-end knowledge graph and AI-based pipelines so that simplify and standardize the process of data loading, experiment setup, and the model evaluation. So regarding the homeless in the US, you may are aware, actually, it reached a record high in the year 2024. So with over 770K people unhoused on a single night. So an 80% increase from year 2023. Okay. And our project is inspired by is following the challenges. So the first is many the people experiencing homelessness, they heavily relied on the local community service to meet their essential needs. And the homeless service results are often subject to frequent change due to the various factors, for example, like the available funding, seasonal changes, and etc. And additionally, there exist big challenges for data collecting and pre-processing. In general, we may encounter the outdated information in the data collection. And additionally, for the police, for the government, they may need the better policy and partnerships to better handle this situation. And here is the overview of the GMKG. So this project will utilize the emergence, the graph learning tools, AI method, and the innovative language model approach for the data creation and analysis related to the homelessness. And the resulting knowledge graph, GMKG, so will feature the user-friendly user interface and offering the easy access to data and the insights, enhancing the service deliverable to the homeless populations. By harnessing the geometry theory, explainable AI, and ontology techniques, so our project here aim to advance the understanding in AI applications and bridge the gap between AI and the homelessness research and offer novel solutions for the homelessness prevention. And from the education point of view, the educational component of this project include mentoring underrepresented groups and incorporating the project outcomes into the various courses. And these project outcomes will be shared broadly, so engaging multiple stakeholders, including, for example, like our federal agency partner, National Institute of Justice, and also some affected communities, clinicians, policymakers, case workers, case managers, and researchers in this community or across communities. So here we aim to address this national the homeless crisis and improve the resource allocation and housing crisis. And next, my student Chenguang will introduce more details regarding the GMKG, this knowledge graph system construction and development.
So I will introduce the DreamKG schema. This schema is designed based on schema ontology, allowing integration with other linked data resource. At the center is the schema service entity. This represents each individual service, such as a shelter, food pantry, or a mental health provider. Each service connects to multiple related components, such as schema place, schema service channel, and we combine this together. This schema will provide a flexible and semantically rich foundation for representing real-world social service ecosystems in a machine-readable way. And now, let's look at how we construct the DreamKG database. We focus on three key service domains: emergency food, temporary shelter or housing, and mental health support. For each provider, we compiled a detailed spreadsheet with information such as name, service offered, contact information, address, and our data collection currently covers Philadelphia, which is completed, and the greater Los Angeles area, which is near completion. When then we then use a post-recycle, auto-WKG, and schema organization to convert this structured spreadsheet into RDF triples to create a linked knowledge graph. This generated RDF was exported into TSV format for downstream analysis with Sparkle, Cipher, and GraphRag interface. We also use a JFI for visualization and exploration. In total, the Philadelphia DreamKG now contains 1,200 entities, 40 relation types, and 2,800 RDF triples, representing one of the most complete structured database of homelessness service in this region. And the third slide showed how users interact with the DreamKG system through a complete AI-driven workflow. When a user submit a query, for example, find open shelters near me, the system first identifies personalized criteria such as the pet-friendly and or family-specific needs. The language model then parses the request and generates knowledge graph keywords like shelter, food, or mental health. These keywords are used to query the DreamKG and connect external cages enhanced by the spider system, which provide frequent queries and geospatial context. The retrieved results are then ranked and refined to use real-time data, such as current service availability. Finally, the LM synthesized a customized response, adapting to user-specific social factors, language, culture, or education to deliver relevant human-centered answers. In short, this pipeline connects knowledge graph, reasoning, and knowledge models to make social service information intelligent, accessible, and personalized. And next, Javad will introduce the interface part.
Thanks, Chenguang. Hi, everyone. I'm Javad. Here I'm presenting DreamKG's interfaces. On the left, you can see the initial version, which includes comprehensive filtering options. On the right, you can see the updated interface, which is designed to be more user-friendly and streamlined. You can differentiate them using their logos in the next slides. The key capabilities of them include multimodal outputs with map visualizations and detailed location-based recommendations. In addition, two functional chatbot systems have been developed and tested on both desktop and mobile platforms. This is a sample response from the first version. The demonstration represents comprehensive service data. A critical feature of the system is the integrated transportation analysis, which displays walking time and available bus options. For individuals who rely on public transportation, this routing information represents essential functionality rather than a convenience. This is the rest of the response, a spatial feature displaying food services near zip code, for example, 19106, using proximity algorithms, and interactive mapping provides contextual service information. And also safety data integration showing crime patterns by, for example, mentioned zip codes. Homeless individuals face elevated crime exposure, so integrating safety intelligence to service recommendations provides situational awareness beyond traditional dictionaries, potentially life-saving functionality. This is a sample from the second version. This section demonstrates technological advancements through natural language processing. The interface evolved from structured filtering to conversational input, and here language chain integration converts natural language into knowledge graph queries. And the multi-layer information architecture delivers concise answers with expandable details, improving readability and decision-making. Our advisory board confirmed that users often need multiple services, so the system optimizes multi-service journeys. For example, here the query, help me find food, a library to print, and a place to stay generates this sequence. Step 1, food pantry. Step 2, library with printing, and step 3, temporary shelter. The interface provides concise summaries with expandable details and turn-by-turn routing. Finally, this demonstrates Proto-OKN project's theme 1 with 4 knowledge graphs unified into one intelligent system. One query automatically orchestrates Dream KG, Rural KG, NIKG, and scales together. Rural KG, for example, identifies high poverty zip code, for example, in 19120, and based on that, Dream KG found 4 local resources, and NIKG revealed 629 incidents, all seamlessly correlated. This is federated knowledge graph technology in action, actually. And moving beyond statistics to actionable detail, you can see complete operational data here. This enables immediate field deployment and precise resource allocation decisions. And here you can see the detailed incident intelligence with victim demographics, wound patterns, and timestamps. The granular data reveals safety patterns and enables evidence-based intervention strategies, real data for real policy solutions. Thank you very much for your attention.